Okay, so hello, my name is Jaskirn Khangura, and I will be doing the problem from Calculus AB 2005, question number 3. Okay, so for part A, the problem asks you to estimate t at 7, so t prime at 7, and it gives you a table. So what you're going to do is you're going to approximate using the slope formula, which is y2 minus y1 over x2 minus x1. And we use this because the derivative is equal to slope. So this would be now, don't forget to put these units because sometimes they give you points. You will get 1 point for this answer, this numeric answer of -7 over 2. Okay, moving on to part B. Part B asks you to write an integral expression in terms of x of t for the average temperature of the wire. Estimate the average temperature of the wire using a trapezoidal sum with the 4 subintervals indicated by the data in the table. Indicate units of measure. Okay, so this is a lot at first, but it's actually pretty easy. So what is it asking you? It's asking you the average temperature. So when it asks you about average temperature, think of the average value formula, which is A1 over B minus A from A to B of that function. So we will do the same thing. And it's asking us to go from the entire table. So that's going to be from 0 to 8, which will just be 1/8 from 0 to 8. And just using this, we're going to do a trapezoidal sum, which means we're going to do height, base 2 or 1, plus base 2 or 1, over 2. For each subunit, and these are going to be our 4 units right here. This is what the problem is referring to. So let me erase this. So 1 over 8 from, we're going to do 100 plus 93 over 2 times 1, that's our height, plus 93 plus 70 times 4 over 2, plus, I'm going to go down here because I don't have enough room, plus 2 over times 1, sorry. Okay, so when you do this all, make sure you divide by 8. That's important because that's your average value part. So the answer will be 75.6825 Celsius. But you can always shorten this down to 3 decimal places. But yeah. So you will get 1 point for this setup of the formula that I showed you earlier with 1/8 over 1 to this, like 0 to 8, sorry. That will be 1 point if you show them that you're doing this. They'll get 1 point for this trapezoidal sum, and you will get 1 point for the correct answer with units. Remember your units. Okay, we're moving on to part 3, or part C, I should say, which says to find the integral from 0 to 8 of t prime x dx and indicate measures, units of measure. Explain the meaning of this and in terms of the temperature of the wire. Okay, so that might be confusing at first, but that's just asking you a combination of the fundamental theorem of calculus and the accumulation theorem, which is kind of weird, but now when you think about it. So they're saying go from 0 to 8 of t prime x dx. So what's the integral of the first derivative? It cancels out, right? So what you're going to do is take the function and you're just going to subtract it from each other, which will give you 55 minus 100, which means there was a decrease in temperature as the wire was heated from one end to the other. Make sure you write this out. That will be 1 point. There will be 1 point for this value, and then there's going to be 1 point for a sentence or like a meaning. When the College Board asks you for a meaning, you should give one, or else you won't get the point for it. Okay, moving on to part D. This is kind of the trickiest one out of all four, but you can still do it. So part D asks, are the data in the table consistent with the assertion that t double prime is always increasing for every x on the interval from 0 to 8, and explain your answer. So how do you find this? Great question. What you're going to do is you're going to find the first derivative. And using what we did in part A, we're going to do the slope formula. So we're going to go from 1 to 5, which is going to be 70 minus 93 over 5 minus 1 equals negative 5.75. And then we're going to go from 5 to 6. And so you're going to ask, oh, why are we going from 5 to 1 and 5 to 6? Well, we're going from those intervals because you see a decrease right there. You see that these values are like decreasing. But okay, that might seem really unclear. You want to choose 1 to 5 and 5 to 6 because there's a shift in the function, if that makes any sense. So you're going to go from 5 to 6, 62 minus 70 equals negative 8. So you see that this function is decreasing all the time since both first derivative values are negative. And you can justify your reason by including the mean value theorem. And so you will get a point for these two slopes, and you'll get a point for a sentence with your explanation using the mean value theorem, or any other justification that you could find that fits this problem. And there's an additional point at the very end, which is like not a secret point, but is still like kind of, it's like a bonus kind of if you read the directions. So you get units if you put Celsius over centimeters in part A, and if you put Celsius for part B and C. So that's your 9th point. So thank you. I hope this helped. and have a nice day.